We are back on our path. It's a beautiful day today, sunny, a little bit cool, but just gorgeous. And we are going to take a little hike, go on our usual beautiful path. You know, this, you might have heard of Beethoven's hearing issues as he got older. I mean, first of all, just amazing music, what inspiration and what change he brought into what music can be. But then as he performed later in his life, you know, he had started to get deaf, and then he got more and more deaf. The critics were not kind to him. They were saying that he was banging on the keyboards really hard, and to their ears it was no longer music. Well, that's because he could not hear the notes, and he had to play them louder and louder. And then eventually he stopped using the bass tones and relied more on the high notes, which affected some of his music as well. And so, you know, we have to ask, what is the role of the sense organs and our perception of the sensory inputs from the neural perspective, and if that can be extended, that can be updated in some way. We talked about this earlier in one of the talks about whether the sensory processing and the actuation processing can be more distributed in our body, and if there is an advantage in the evolutionary sense for doing that. That's what we are going to talk about in our hike today. You know, let's start from the Beethoven case. Now one could say that, gee, can we have more redundancy? You know, have two more sets of ears or something like that. But I don't think that is the solution here. Because then what if that fails and so forth, right? Because the failure might not actually even be in the sensory organ. It could be in the in the brain, the neural system, which is more unified. And so then, are you going to ask for redundancy of that? Maybe yes. So in the Beethoven case, let's say his sense organs were as they were, you know, like all of us have the two ears and the unitary processing in the brain, but that he had a special way of understanding the notes pressed on the piano. You know, his fingers were sensitive to the pressure on the piano and could, in a sense or give him the sense of the loudness of the note that was played. Could he then have, you know, produced music that was more pleasing to the critics, even though he could not necessarily have heard it through his normal ears? You know, could there be a secondary mechanism which gives him a sort of secondary input to regulate the actuation in the real world that he is doing. If you study the propagation of neural signals, there's a fantastic chemical process of how the electric voltage changes the polarization of the ions, and that propagates as a pulse through the neurons, connecting them back into the brain. And experiments show that the speed of propagation is something like 100 meters per second. So roughly, a football field in a second. And then if you look at the delays, for example, in automobile driving, they tell you what is the reaction time from seeing a dangerous situation on the road to responding to it with braking or something like that. That's about 0.2 of a second. And let's say we have a meter of neural space to traverse. So 100th of a second for the signal to be transmitted up from wherever we see it or sense it to the brain, and some processing, actuation, etc. 100th of a second back to the muscles. Then the muscles have to fire and actuate, and finally you take an action about 0.2 of a second later. There's also, how we see videos. There is a persistence of vision for about 1/10 of a second. So if the images change roughly 1/10 of a second or faster than that, then we see that as a continuous motion. And if it changes less frequently than that, we sense that as a jerky or perceptible sequence of slides as opposed to video. So in a way, there could be a benefit to be able to speed up that reaction time. In a sense, what I would call the regulatory loop of the sense process act. Yet, we have to coordinate so many different signals from different senses to be able to take that action. It's not a single sense from a single place that typically informs the action that we take. So even if we had some sort of local processing of the sense signal and then actuation, would it not be incomplete action that then we would have to reconcile with the other signals that are coming in? So there is perhaps some value in the regulatory loop in some situations, perhaps like this Beethoven case, where if the fingers could inform how loud the sound was without having to clang the piano too hard, it could have helped him. Or you could think of other regulatory situations. For example, in sports, maybe you're fishing, fly fishing, and the subtle changes in the sensory perception of touch in your fingers tells you what kind of action you're getting from the fish, and then helps you catch it better. Or maybe in baseball or any of these sports, the regulation of the bat, independently of how you perceive the ball, and the regulation of it as you strike it through could be helpful. So is the regulatory function becoming faster important in the human context and in the evolutionary context? Typically these things depend on the sensory development depends on the environment in which we are placed and in which we have to succeed. And given that we have more and more automation, mechanization, robotics, computers assisting us, tools, artificial intelligence, whatever you want to call it, machine learning, assisting us, seems to indicate that just speeding up the regulatory function is not necessarily the winning strategy of spending our evolutionary energy. What about other functions of distributed processing? We mentioned in a previous talk that the optic nerve itself does a lot of processing as the raw visual signal goes from the eyes back to the optic center in the brain. And so what is the kind of processing that is happening in the nerve itself? We are doing things like edge detection, shapes, abstracting features from the raw image that our rods and cones register in the eye, and trying to form intermediate structures, including semantic structures of relationships and what is in the front, what is in the back, 3D kind of imaging relationships, even as it is passing through to the optical center. And then of course higher level processing happens after that, mapping it from memory into recognizable shapes, and then into higher level constructs such as relationships between those shapes, and based on memory, what we can expect out of that. If there is motion, what can we simulate that motion forward into, and then how to act in that forward simulated world so that we are effective in the real world. So I would say, in addition to just raw signal propagation and faster propagation, the abstraction, the symbolic extraction of features, and then relating it into a semantic structure are some of the processings that are happening in that pathway. And those seem highly valuable. So can these semantic processing of sensory information be distributed? And can we do more of it? Like, do you need all the memory and other higher level information in the brain to give context for the symbolic or semantic processing of the sensory input? And likewise, for the translation of the semantic or symbolic actions to be taken back to the regulatory actions of our muscles and our actuation entities. I think it's a balance. Some things you can do independently, and some things need the overall context, including the coordination of other senses. And to the extent that we can distribute the translation from the raw sensory signal to some sort of symbolic or semantic information, and then the other way, translation of symbolic and semantic information to actuation signals, that should be helpful for the overall better understanding, better action in the real world. The development of sensory organs and the development of the actuation organs does not occur in a vacuum. It is always guided by the stimulation from the environment and the rewards from the environment. So, what environment will we be in the future that should guide the development of these new sensory and actuatory apparatus, instincts, if you want to call it that. I think the physical world we have, more or less covered with our sense organs and the technology assists that we have gained from all the science and engineering. And same with acting in the real world. We have developed a lot of machines that can help us with that. We are starting to develop, if you think of language, it is essentially a social construct because it supports communication. You can say that it's also an individual construct because it supports abstract thinking, understanding the structure of things, going into the math and science of things and so forth. But language is a communication construct, and communication happens in a social setting. So, we have developed the apparatus to help us in a social setting in groups of whatever, tens, dozens or so. What if we are placed in a highly scaled up social setting? Thousands, millions of people that we have to interact with, understand, explain to, act in, and so forth. Do we need a different kind of sensory apparatus? Do we need a different kind of actuation apparatus? Perhaps a different kind of understanding. This also goes a little bit to what we said in a previous talk about connecting the micro and the macro. Essentially, from a scaled up set of micro interactions, can we understand more of a macro picture? If you look at many cases where essentially popularity contests are involved, these could be elections in the democratic settings, these could be winning beauty pageants, being the most popular artist, whatever. There's a sense of aggregating the likes and dislikes of a lot of people, and then understanding that, reacting to that, winnowing out your supporters from your detractors, and then fostering one group, minimizing the other group, etc., which are all like mass actions. And there's a fine-tuned sense that some of these players have developed, whether politicians or artists or whoever is interested in popularity contests, to do that. Here's another view of our rock. We have reached the rock and we can climb up today for sure. That's the cathedral of tall trees right there. we are already developing tools like social media tools that help us aggregate various social perceptions and I'm stepping down here, perceptions, and help us figure out how to behave, act in that social world. And obviously it has repercussions because the choice of people that you associate with, potentially select partners for procreation, etc., is going to guide to some extent this whole notion of self-selection and evolution. The thing is, though, there's no fundamental truth to these social acceptance, to the popularity. It is highly cultural, and it'll guide the development of that culture and the supporting population to some extent, but there is no fundamental truth such as you think there is fundamental truth at all in the world. But it seems very superficial, very facile, kind of a metric on which to base evolution. I mean, though we have to admit that evolution is what it is, in the sense that people come together, form the next generation, transmit their characteristics, evolve, etc. And if social popularity is what drives that, then that is also a driver of evolution. But it seems arbitrary of a cultural construct, and in the case of fundamental choice or difficulty or scarcity or survival, it is likely to drop off. So is there something more fundamental, more sort of aligned to truth that also is somewhat involved in these aspects? We are back at our mini gorge, and let's go past and see what is in there, what the rains and the storms have brought here. Nice forest. All right, let's exit out of here and we said earlier that the sense organs develop based on the stimuli of the environment. So is there an environment that is more aligned with a broader, more complete, more fundamental truth in which to develop the new sense organs? And this again goes back to our previous talks, where we talked about the feeling of oneness, of unity, not just in a social context, but with all life, with all existence. And that's a very subjective experience, a very subjective environment. But we do perceive it. Those who do perceive it have a very concrete sense of it, and they have a sense of the development of new sense organs that operate in that space. And with that comes a new kind of actuation, kind of power to act in that unified space. And a new kind of vocabulary, language, terminology. And if that can be made a common experience amongst a few people with a much more quantified, understandable basis of communication for it, that seems to be a possible direction of evolution of the sensory, actuatory, and sort of distributed nature of this processing. I think it is possible to imagine a situation where we evolve to have this much more distributed, much more densely distributed neural layer that goes from our various inner and outer sense organs and translates physical and occult phenomena into a macro level picture, an integrated, unified picture of the reality around us. And then we act in that environment. That's like saying we have this potential for a luminous sheath that covers our whole body, physical and occult, and makes it more concrete, living in a more integrated reality of the physical and the occult, spiritual kind of a world.